All right. Let me make sure. Yep. Volume looks good. Let me pause a couple of these previews. Make sure we're on the right scene. Okay. In just a few more seconds, let me shuffle around some windows so that I can see the chats. And then I will get started. Okay. So this is some work I started a little while back. I have a repository for it. Let's see. It says 6 months ago is the last time I pushed to it. So I started this one day on a stream, and it's basically a tiled, the Tilemap game software. This is called Tiled. You can find it online if you search for Tiled map editor. Let's pull up the page for it, actually, since we're here. Tiled. It's map editor software. So this is a piece of software you can use to create tile maps for games. And it has support for lots of different game engines like Pygame and Phaser as a JavaScript game engine, lots of others I'm sure as well. And so what I was working on is making a CircuitPython helper library that will consume the maps that get saved by this program, and it will allow you to display them on CircuitPython devices like the Pygamer, which I have here. But of course, once we get this working, it would work on pretty much any CircuitPython device. We'll have to have a display, but that's kind of the only thing it would require. It would run on pretty much anything you wanted to do. So this is the repository for it. I had this set up a little while ago. CircuitPython tiled game experiments under Foamy Guy on GitHub if anybody is interested in taking a look. And like I mentioned a minute ago, it's been a little while since I did anything with this. So probably the first thing I'm going to do is just kind of take a look around and see what state I left it in, just because it's been a while since I have messed with it. So I have this opened up in PyCharm as well. And the first thing actually that I'm going to do is check to see if there is any new progress on the Pygamer that I did not check into the repo, because I'm not sure if that's the case or not. The other thing I'm going to do actually is open up a device workspace. I'm going to open up this PyCharm so that I will have the CircuitPy drive. And this is in a file called tiled game map, excuse me. And I will, let's see, what will we do? We can just copy all of this, maybe. We can come on back to this repo. We can find the same file. We can paste this, and we can check the difference. Okay, so there is some differences. So let's just take a quick peek through what some of these differences are. Let's just white space. So we changed some default locations. Camera location. Cursor. Looks like the cursor didn't used to exist, so maybe we added the whole cursor. Yeah, it seems like... Oh, and actually camera location as well. Maybe we added cursor logic and camera logic, or did we only start working on those things? Let's take a little bit of a peek further. Update the player location. Update the cursor location. Get tile name. So it doesn't seem like we do have camera logic. Let's see if anything uses load tile grids. Does anything use camera lock besides this? Let's look here. Camera lock. It's weird, we're setting it to 1, 1, but then we're just setting it to 0, 0. immediately after. I'm not sure what that's all about. So you could probably tell that, it's been a while since I messed with this code. So what did we, didn't actually go to it here. Okay, well, we definitely have differences. Put the sprite somewhere, put the initial player location, update the cursor location, load tile grids. It's X and Y. What are X and Y? Load tile grids. These are inputs, arguments to the function. Camera lock X. So maybe we do have camera logic build tiles list, because this is load tile grids. This is accepting an X, Y, and a width and a height. And the width and the height are equal to the number of tiles that the size of the screen is. So the tiles that we were using in this example were 16 by 16. Those make for a pretty good size on the Pi Gamer, and the size of the screen matches up with 10 pixels wide, or not pixels, but 10 tiles wide and 8 tiles tall. And then we did set the camera location to whatever got passed as XY. Place the player at the player lock modified by the XY that got passed in. Okay. Update the player location. Okay, so there is some camera logic there when we change the player location. So it does seem like maybe we do have some camera logic. We have a get tile. Okay, so there's definitely some changes. So I'm gonna keep the stuff that I got from the Pi Gamer. I'll even. Do we want to push right now? No, I think let's just keep it. Let's keep it without pushing. So let's get the sample code running. Let me see here. Game test 0. This is for the Pygame display IO. Pygame Blinky display IO. Map 0. So does this run? Let's see what state we're in here. Does. Okay. Doesn't have the cursor. And it seemed like that map was the exact same size, maybe as the display. So what did we do here? We did 160 by 128 times 2. We scale? Display show, tile grid. It did. Yeah, entity group. It's scaled by 2. Also castle group. Okay. So that made it a little bit bigger because, obviously this runs on the PC and the screen is much larger. We have a lot more pixels to work with. So technically this is the same size as the Pi Gamer screen, but everything is scaled up by 2, just so those 16 by 16 pixel tiles actually end up being 32 by 32 on this screen, since we got lots of place, lots of pixels to work with. So next, what does this do here? A lot of prints we could get rid of eventually. L-index. Okay, so some of this is the original. Some of this is the original Tilemap sample code. So if you did not happen to watch this the first time around when I worked on this, if you're interested in playing around with Tilemap games on CircuitPython, there is kind of some base knowledge that you need to understand, which is one good place to check is this Tilemap game learn guide that I wrote a while back. This is creating the same kind of game, but the maps are not coming from tiled. in this Learn Guide, the maps were written as CSV files, so you could update them with like Excel or any other comma separated, like any other Excel type program, spreadsheet program. But if you are interested in learning this stuff, some of the core like foundational knowledge that you need to have is linked right here. This basic rendering code, it links over to this multiple tile grids, which is in the display IO guide. And these are the principles that everything that we do with tile maps is built on top of. So if you are just starting out trying to get into this, this would be the stuff that I would recommend looking into first, and make sure you have a really good understanding of what this page is talking about and how it is putting together, what you ultimately see on the screen. Because this talks about how the tile grids work, talks about how you assign, indexes to each of those locations in the tile grid, and it talks about how those indexes get mapped back from the sprite sheet, and how it all comes together to create what you see on the screen. So this is really the foundational knowledge of the tile map game. So definitely take a look at this if you're interested in getting started. That's what some of this sample code here is from. But it is all commented out for now. So let me see here. Which map is this loading? This is loading. Well, actually, this is not using the helper module. Yeah, this is not using the helper module. Is this? Doesn't look like it. Well, yeah. No. This is loading from the JSON that Tiled exported. Map 2. Yeah, this JSON came from Tiled, but this is not using the helper library at all. Okay. This one is. This one is. Okay. Location changed. Okay, this one has buttons. All right. Let's run this on the Pygamer. Actually, though, let me check. I may have code on the Pygamer already. Let's make sure. Called game code 0. It's using. It's not. See if we have the one that's using. This one is. Okay. Good map 2. So let's see if this is the same. It's not though, right? This is 73 lines. This is only 58 lines. So let me bring this over into the repo. File map render. Just copy it as is. I'm gonna name it Pygamer, because it looks like it's set up for the size of the Pygamer, and it looks like it's set up for the buttons on the Pygamer as well. We can add that to Git, sure. Let's compare these two. So code using map object. So let's compare code using map object. Compare with. Oh, how do we do that? Else. Compare with. Programmer title map render. Okay, so it's almost the same. There are a few differences. Initial player location. New location. Cursor. Check out some prints. Tile movable. Okay, Update cursor location versus update player location. So it looks like this one is moving the cursor and not the player, whereas this one is moving the player. So let's get this running on the PyGamer. Device workspace. So what is in my code Pi? PyBadger test. Okay, we don't need that. Need that. We can delete that. Actually, let's just keep it. Let's erase it though, and then we can just copy this stuff into it. Okay. Did that. What do we got? Okay. So we have a little cursor. We can move the cursor around. Goes off the screen. Okay. So we would want some logic to keep it from moving off the screen. Realistically, we probably would want some logic to pan the camera around if the map is bigger than the screen. Which I don't know if that's the case. Let's look. So this is good map 2. So let's go. You know, one thing I want to do is add a Readme to this and leave some notes about how to open and change and save the files from Tiled. Because I figured all of that stuff out. There's kind of a specific way you have to do it, but I didn't document any of it. Which I should have. So let me add a Readme. Readme.md. Yes, and we'll start documenting that here. So opening, I think. There's no import, so maybe we can just do open. So let's go open file or project. Let's go find this one. File games. We were looking at good map 2. Open. Okay. So that did work. So let me make a section here. Open Untitled file open and then just choose the JSON file. Find and choose JSON file. And we'll make some more notes as we go for how to save it and how to set up a new one and some other stuff like that. So, all right, let's look next at this map. So this map is actually bigger than the screen. We have a bunch of stuff outside of the screen here. So let's check if the camera works, because if the camera works, then we'll be able to scooch this over and display some of those things that are outside the walls. You know, those things wouldn't make sense in an actual game, right? Because we have walls here, so like we wouldn't be able to walk through the walls probably. So we wouldn't really use a map like this, but you know, we can use it for testing. See if the camera is working. So let's look back inside of CodePy and see how this works. So we create the tile game map, pass it the JSON, show main group. We append my game into main group. The tile map game extends group, probably. Yeah, group. Okay. Set up the buttons. New lock, moved true. Lock change. Cursor, update cursor location. We have extra logic on the left button. Get tile name. I probably was trying to test get tile name or something. That's my guess. So where do we render? It seems like we're rendering inside CircuitPy. What changed? Let's go look inside of here. What all happens when we initialize? Load the JSON file. Also, this is hard-coded right now. We should read it from this. Okay. It has tiles. Loop over the tiles. Set up a dictionary of tile properties. Set up a variable for the sprite sheet image, load it with image load. Make 0 transparent so that there's probably green or pink or something. Let's look at which file it's actually using. So, Map 2. Map 2 uses find BMP sprite sheet new BMP. Yeah, green. So we have this green color in the background. Green must be index 0. And so we're setting index 0 to transparent so that the green won't get drawn on the screen. That's how we handle transparency. Set up a background tile grid. Why do we need a background tile grid? This is 10 by 8, 16 by 16. The default tile is 15. And I think these are like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So blank. Castle tile grid. Oh, I guess we have a background. Yeah, we have a background so that we can have entities on top. Right, because we want the entities like Blinka and the robot and Ohm, the resistor, and Sparky and Minerva. We want all of these to spawn to be shown on top of floors, right? We don't want like a blank black hole tile or whatever with just Adabot drawn on it. We want a floor, and then we want Adabot drawn on top. So that makes sense. The floor would get drawn on background tile grid. The entity, so Adabot or Blinka or whoever, whatever, would get shown in the entity tile grid. And then I guess actually the sprite tile grid, Blinka, which in this case Blinka is the player, is what we're calling the player. And Blinka gets treated a little bit differently. Blinka gets her own tile grid, the sprite tile grid. All the rest of the entities go inside the entity tile grid. Okay. And we also have a separate cursor tile grid, which basically works the same as the sprite tile grid. It's 1 by 1. This one uses default tile 17. It's interesting we don't have 17. So we must have updated this on the Pygamer. So let's go grab this file. That was what, new sprite sheet 2 or something? Sprite sheet new. Yeah, this one has a cursor in it. So let me bring this over to the repo. Right. Okay. Now we have the cursor. Okay. Let's head back to here, cursor tile grid. So we append all of our different tile grids into our self, which is the group. We call load tile grids. We update the player location to the initial location. We update the cursor location. Okay. Load tile grids. So this is what gets called here. Defaults to 0, 0, 10, and 8. Camera location gets set to XY. Build the tile list, layer index. So inside of tiled, we have two different layers. We have the background layer, which is everything we see here, basically the floors and the walls. And then we have the entity layer, which are all the things that get spawned above the floor. Okay, we turn those on and off individually using these little eyeballs. Okay. Let's take a look here. We're looping over the height and width. Extra offset is equal to the map width minus the width we got passed times the current Y. I don't know why we have extra offset. We should make, once we figure that out, we should make a comment. Tiles to load. This is going inside the map object, inside layers, inside layer index, inside data. Okay. So the thing here is inside of the JSON, this is how the data is stored. We have, let's find it. Yeah, layers. We have an array of layers. Inside the array, we have two of these objects because our map has two layers. We have data, and inside of data, it's a single array. It's a single array, a list, with indexes representing the tiles. So you would think maybe that it would be a two-dimensional array to represent the X and Y dimensions of this map, but it's actually not. It's a single dimensional array, just a regular list, and it just breaks down to, you know, X number of tiles. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The first 12 tiles are the first row. The next 12 tiles, the next 12 indexes are the next row. The next 12 are the next row, so on and so forth. So every set of 12 indexes in here, I don't know if I highlighted 12 exactly, but every set of 12 indexes represents one row inside the map. So let's go back to here and keep stepping through the code. Tiles to load. Tiles list. So this is just tiles to load. This is just loading all of the indexes from this rectangle, right? This is representing a rectangle. This is the top left coordinates of the rectangle in tiles. 0, 0 tiles. The first, you know, X tile, the first Y tile, and then the width and the height of the rectangle. We're loading the indexes from all of those tiles inside the rectangle into this list, tiles to load, and we are returning that. So we would end up with a list basically pretty much the same as the one inside of the JSON file here, but we would only have the section that we care about. We would only have the section represented by this rectangle, which is essentially the camera. This is the part we can see on the screen. So setting extra offset again, we'll still need to figure out why we have extra offset. I'm still not sure exactly why we have that. Map width minus width times y. I mean, in our case, it's actually 0 because, well, no, well, down here it's 0 because y is 0. In here, I guess it changes. It's 0 the first iteration of this for loop, but then it would not be 0 anymore after that, unless these happen to equal out to 0. Okay, start index. Y times width plus x times x plus y times width plus x plus extra offset. Start index. Looks like maybe we tried to do this logic using slices, but it probably didn't work. We commented it out. That's my guess. Background tiles, build tile list 0. So calling build tile list, passing the layer index of 0. For index and tile index, enumerate background tiles. Create XY variables. Index over width. Index modulus width. Background tile grid. Set the XY equal to the tile index that we got out of our background tiles. And I do remember, I'm going to put this in the Readme, inside of the JSON, oh, I was going to say inside of the JSON, these are 1-based. That's not true. Well, maybe they are. Maybe they are. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 11. We have 2 different things. Oh, but they're both floor. In the background, they're both floor. Right, okay. So let's find out which one this is. So if these were 0-based, 0, 1, 2, 3, 4, 5, 6 would be top left corner. But we have a 7 there, so they are 1-based. 7. So these tiles inside of the map, the map JSON that we got from Tiled, our game map editor, these are 1-based. If we put Blinka into a spot on the map, like we have done here, we would get a 1 inside of that layer. So this is the entity layer. Somewhere inside of this, we'll have the 1. And this 1 right here is Blinka. So these are 1-based. I'm just going to make like misc info section. I'll organize some of this better later on, but let's just dump what we find, and that way hopefully this will be easier to pick up next time. MISC info, so tile indexes inside of tiled JSON maps are 1 based. 0 index represents nothing in that tile. So that's why, back to the JSON. That's why we have a bunch of zeros here. All these zeros are in squares where we don't have anything inside the entity map. Anywhere where there's nothing in that square, it gets a 0 index. But in CircuitPython, it's not 1 based, it's 0 based. Where's the code? This is the code we're stepping through. So that's why here we say tile index -1. Because inside CircuitPython land, you know, for instance, Blinka's index is actually 0, not 1. We have to subtract 1 to equalize. So this is loading everything into the background tile grid. Build tiles list, entity tiles. So this is calling this function again, but on the entity layer. All this logic is pretty much the same. If the tile index is not 0, if get tile property, so if it's not equal to 0, so if there is something on the tile, remember, because if it's 0, there's nothing there. If there is something on the tile, if the property is player. So inside of here, we were able to set properties. We have this player right here, custom properties, player. And if we click on each of these things, we can see the value. Which it seems like actually can walk. That's another custom property. It seems like actually we have Minerva and Sparky and Heart on true, and Blinka of course as well. So we should actually turn off Blinka. Oh, this is can walk actually, can walk, not player. Can walk. Okay, so player, the only one that has player with the check mark is Blinka. So that makes sense. And then inside of our code, this comes through as a tile property, which we basically fetch out of our tile properties dictionary, which we created and filled back here while we were instantiating the map. It is a dictionary of tile ID. These have IDs in here? They do have IDs. They're just numerical, 0 index based. If it's not already in the dictionary, add it to the dictionary. Add a blank dictionary to the dictionary. Then loop over all the properties inside of tiles properties. This is in, I think we must be in tile sets probably. At tile sets, 0 tiles. So we're just assuming a single tile set, basically. Tiled actually supports multiples, but in our code here, we're kind of assuming a single. So let's go back to the JSON. Tile sets, tiles. Each one has an ID. Each one has a list of properties. Each property in the list is an object. It has a name, type, and a value. Okay. Keep mixing up which PyCharm I'm looking at. So basically we are looping over all the tiles. And this is while we're creating, essentially while we're setting up the entity tile grid, and we're saying if the current tile is the player, the thing that has player true, the thing that has the check mark on player here, which in our case is just Blinka, if we found that thing in the map at this location, then set player lock X and Y equal to the current X and Y that we are looking at inside the map. Else, if it was not the player, then just put it in the entity grid. Whatever we found there, just put it in the entity grid. Else, if it was 0, then just put empty space. And we're putting empty space by setting it to tile 15, which happens to be one of these two blank ones. ID 15, that would be this one. So we have to keep a blank tile inside of our sprite sheet. Honestly, we should refactor this so that tile 0 is blank, I think, but let's make some notes about this. Yeah. Space. Must be set to index for empty spot in the sprite sheet. Okay. I think it'd be better if this was just not randomly 15. It'd probably be best if it was 0, honestly. Maybe 0 for empty space, 1 for the player, and then everything else after that. So inside load tile grids, this is where we're filling the two tile grids, background tile grid, entity tile grid. It's also where we're setting the location of the player, which is, I suppose, probably sprite tile grid. Although we are just setting player lock, which is just the dictionary. We're not actually setting the sprite tile grid inside of here. Must be somewhere else we're doing that. Okay, some helper functions. Get the map object, get the tile properties, get a single tile property. Update the player location. This is where we set the sprite tile grids, X, Y, and we set it according to the player lock. and accounting for the camera. At the cursor location. So cursor and player pretty much works roughly the same. They have separate tile grids, one for the cursor, one for the player, but they're both 1 by 1. They both work roughly the same. The idea is the cursor is kind of like an entity, but not really. It's not. It gets drawn like an entity on top of the map, but it doesn't interact with anything. The idea would be like you could highlight something with the cursor and like push an action button, which would then give you the list of actions that you can do on that tile. Is tile movable? Check the can walk property of the tile at the given coordinates. Takes a dictionary with XY coordinates. It should probably be a tuple. Well, I guess we're using XY though. Can it be a named tuple maybe? I don't know. True if the player can walk, false otherwise. So this is just looking at properties. It's finding the can walk property. So this one is a wall. Can walk is false. It doesn't have a check mark. This one is also a wall. It doesn't have a check mark. This one right here is a floor. So can walk is true. It does have a check mark. So what we also have is that Adabot and Ohm both have can walk false, but Minerva and Sparky and the Heart all have can walk true. They have the check mark. So this is all basically just looking for that can walk property at the location that you asked it for. Get tile. Let's make a comment for this function. Takes tile chords. These are the same. So what does it return an index only, or does it return? Yeah. Returns the index of the tile at that location. Basically, it returns whatever's in this list at the location that you requested. So it's important to note that would be the what I'll call the tiled index, tiled with a D because it's from the program. So that's the 1-based index. So theoretically, if you gave it the coordinates for Blinka right here, use the cursor. If you gave it these coordinates, it would return to you the index 1. Tiled index for... Although, what layer is it looking in? Layers 1. Oh. So it's looking in the entity... It's looking in the entity layer first. If it finds an entity, it's returning that entity. But if it doesn't, if that is 0, if there's no entity there, then it's looking in the background and returning you the index of that. So tiled index for the entity at the location given, or if no entity is present, turns tiled index for the background tile at the location given. Tiled indexes are 1 based. Okay, get tile name. So this is just getting a property called name. Which we're not filling in. So I don't, unless that's filled in, is that filled in some other way? I think this would not work until we filled it in. Let's look in the JSON again. Has properties, tile sets, tiles, ID. Yeah, there's no property called name. This property has the name player, and so the property is player. This property's name is can walk, but there's no property whose name is name. So this would fail. I think this would not find anything. I think this would not find anything. Let's try. Are we calling this ever? Get tile name. Get tile. Okay, this must be what we were working on. If the left button was pressed, try to print the name of the tile that the cursor is on. So is that just printing nuns, or what is that printing? Let's go to the camera. So let's put it on AdaBot. I'm also not sure if it does it before it moves or after it moves, so I'll put it after AdaBot. The right of AdaBot. Let's get a terminal with TO serial. Lock changed. Lock changed. Okay, so that's actually not. It's actually not printing anything besides lock changed. Which it does when we move right as well. So let's make this is the O button. We're using Ugame for the buttons, which helps make our code agnostic to different devices. Ugame, or I think it's supposed to be microgame, maybe. Kind of like how ULab is microlab. This is a library. Well, it's not a library, it's built into the core, but it's a module that has a bunch of tools for helping you make games. I think it was created by Deshipu, actually. Let's pull up the docs for it so we can see what we're doing here. CircuitPython docs Ugame. So it actually has, stage. It actually has some stuff in it for sprites and drawing and maybe physics? Have physics? Movement. Maybe not physics exactly, like, doesn't have gravity and stuff, I don't think, but does have movement. So, like, you can move XY coordinates of your sprite. And Deshipu made a couple of games using this library, but, not library, but module. But what we're using is not any of the rendering stuff. Instead, we are just using the buttons, which come from, it's actually called Ugame. Not stage. I think the Shippu made both Stage and Ugame. I have like, oh yeah, where's that? Bookmarked this page because it's awesome. But it is in my other browser. Ugame. Not found. That's interesting. Found. Really? You name. Oh. I like using that index page because this search tends to be a little slow. Stage. It just gets me to Stage. Stage module contains native code to speed up the Stage library. Is Ugame in here? Where does Ugame come from? Ulab. Heap. Which is not listed here either. Huh. Underscore Stage. New game. How did I find out about this? Buttons. This is what I'm using. Python Stage. Ah. New game. Buttons. These are the buttons we're using. And each different device in its core build has these buttons declared. So up, down, left, right are pretty straightforward. But then there is X, O. I think there's a third one too. V maybe? X, O, V or something? Does what is it? Pew Pew QM4? We can't see the silk screen. Z. XO and Z. So this doesn't actually document Z, but Z does exist. Maybe we should make a PR with KZ. I don't know what the K stands for, but all the buttons are prefixed with K. There's an X and a O and a Z, and some devices have a start and a select. And so this is actually KO, which is not the left button at all. It's probably the O. I think O is like the enter button. I think it's probably the A button on the PyGamer. So let's put the crosshair on Adabot and press A, and it says Adabot. Interesting. So where does it get that name from? I thought that would not work. Where do we get that name from? Map 2. Or do we have a different JSON which does have names? Maybe we have a different JSON which does have names. Yeah. Okay. So let me take bitmap 2 from the device, paste it into the repo, overwrite this. And that's probably the main thing that changed, yeah. Names. I have names on all of these. In fact, that's probably the only thing that changed. I don't know what that would be. Next layer ID. I think we're using it. Target changed. Okay, but that doesn't matter. Okay, so this does work, but only because we actually filled in the names at some point on the device. iGamer device, okay. So how would we... Pi. A cursor location. So how would we move the camera? So internally, we would call load tile grids, and we would pass a different XY. Right now, the only place where we're calling this from is right here in the constructor. Yeah, this is in the constructor. That's the only place we're calling this from currently. So we need a public. I mean, this is underscore, which means it's meant to be private. It's not supposed to be called by stuff outside of this object. It can, because Python doesn't care, but it's not supposed to be. So, but we need a public API. We need def set camera lock self tile chords So this is actually setting camera lock, the variable camera lock, to the XY that we pass here. We don't need to update those. Those get updated inside of here. Although there is... point to be made that maybe they shouldn't be, but I think let's leave them for now. Layer lock, cursor lock, camera lock. So inside of here, do we just call self.load tile grids and then this takes XY, right? Instead of a dictionary, so load tile grids X equals tile chords X, Y equals tile chords Y. And we'll just leave defaults, I think. At some point we'll mess around with screens of different sizes, and then it would be important to pass different heights and widths, but for now I think we'll just keep the defaults. So set camera lock. We can give it a new location. It will call load tile grids. So let's save this. Let's go back to CodePy. And let's say before the while loop, what's the name of my game? My game dot set camera lock x. Let's move it to 1-1. Yeah, let's move it to 1-1. So if this works, then we'll see the right edge and the bottom edge of the walls scooted up and to the left by one tile, and we'll see this column of Sparkies and this row of hearts and ohms. If it works, that's what we should see on the screen. So let's save it. Yeah, that is what you see on the screen. Okay. So we actually have camera pretty much working. We didn't have any API for it, but that internal function does pretty much all of the work that we needed. So why don't we make it to where, let's make it to where if you move the cursor off of the screen, it will scoot the camera. It will scoot the camera to try to keep the cursor on the screen. So new lock X. So basically we want to know if new lock X is greater than the width plus the current X of the camera. But do we have the width anywhere? Map object width. This is in tiles. Height is 10. Width is 12. Okay. Oh, these are on the layers though. About the full map object. Yeah, 12 also. Okay. Okay. Map object width. So there is a question to be asked, like, should this get handled inside of the game object? Like, when you call this function, should it update the camera? Or should it be CodePy's responsibility to update the camera? I think for now I'm going to do it inside CodePy, but eventually I think it's probably going to be good to move some more of this stuff inside the MyGame object, so that way the CodePy can be simpler. Like, you can just tell the cursor to move and the camera will do something that makes sense without you having to care in CodePy. But for now, let's do it here. If new lock X is greater than MyGame dot map object width minus, we want to minus MyGame dot camera lock X. You want a minus? Yeah, I think we want a minus. We'll find out when we try it. I'm a guess and checker a lot of times. If you've watched my stream before, you know that kind of. If new lock X, then we tried to go too far to the right, so we want to go MyGame dot set camera lock. Let's just add one. Add one. MyGame dot camera lock X +1. So we also need, if we went off the screen to the left, if new lock x is less than camera lock x, it's less than camera lock x, then set it to the current camera lock x -1. Scoot the camera to the left 1 tile. And we need basically the same logic for y. Whoops, we don't want that indented though. If y, new lock y is greater than height minus camera lock y. Oops. Oh, also we need to pass this as a dictionary. We should probably equalize all the APIs. Like this is taking XY as two variables. But some things, like this is taking it as a dictionary. I guess all the public ones are taking it as a dictionary. I wonder if it's more efficient to do 2 ints and to create a dictionary, but let's not worry about efficiency right now. So we're not passing enough stuff here. We need to pass a dictionary. This is X, and Y will just keep the same. Y mygame.cameraLock Y dictionary. Close the dictionary. Okay. So I'm gonna copy this line. Just over this, change this to minus. Whoops. Minus. There we go. Okay. Now, for Y, we have, again, basically the same logic, but X will stay the same. And here, Y will get bigger, +1, Y will get smaller, -1 here. Okay. So if the new location is outside the bounds of actually, we don't want the game width. We don't want this. We don't want map object width. Really what we want is the map width. Or not the, excuse me, not the map width. That's what I just said we don't want. We want the camera width. We want the camera width, which is generally going to be the same size as the screen, at least in these basic examples that we're making right now. So it would be this width right here, which we've just hard-coded. Everywhere. So I guess we just hard-code it here. I think eventually we should make camera height and camera width be variables that you can set on my game. But for now, we'll hard-code 10. 10 is the size of the camera. The camera's 10 by 8. 10 by 8, is that right? I think that's right. Bigger. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 10 by 8 is the size of the camera using this size of tiles on this screen. Again, we've got hard-coded for now, but eventually we'll tweak to be able to adapt to different size cameras. So that way it could adapt to, again, different size screens or different size tiles. So in this one, we don't care. We don't care about the width because we're going down. We're basically just caring about 0 or where the current location of the camera is. So here, actually, though, these would be Y. We didn't change all of these. These need to be Y. This needs to be height, but we don't want map height. We want camera height, which is 8. This needs to be Y. Okay. This needs to be Y. Okay. If the new location is outside the bounds of the camera, basically, that's what this logic is saying. If the new location is outside the bounds of the camera, then update the camera location to move it in one direction, whichever direction the new location is going. And then after that, go ahead and update the cursor location. And yeah, render. This is rendering the cursor so that it gets rendered at its new location. Okay. So this API is kind of weird as well. We're changing the cursor lock here by just saying cursor lock X equals new location, cursor lock Y equals new location, and then we're calling update cursor location. I think either we should be passing XY into this. So like we're saying update the location to the argument we pass, or this should not be called update and instead should be called like render cursor or something like that. That indicates that it's like drawing the cursor on the screen at that location, which update sort of kind of conveys, but not all the way, not exactly. But let's not nitpick the API too much right now. So let's see if this works. If this works, then we can move the cursor outside of the camera, and the camera will move itself to catch up. If we go all the way out here. Okay, so we're off by 1 because... Ooh. We're off by 1, and also something crazy is going on when we move back to the left. Interesting. Let's restart. Changed. Let's print new lock. Print new lock. New lock is 1, 2. One 3, 1 4, 1 5. No, this should be plus. Should be plus. Yeah, this should be plus. It should also be plus. Yeah, because camera lock is positive. We would care about camera width plus camera lock. Camera height plus camera lock Y. So why is my first one Let me restart again. Is my first movement always going up, or am I just accidentally hitting up? Joystick here. I'm gonna go right. Yeah, I definitely tried to go right. Am I just accidentally going up? Do we have a bug that's causing it to move? So weird though, because after the first one, everything works fine. Down? And down went to the left. Yeah, we definitely have a problem. We have a problem. I think set camera lock. This needs to call update cursor. Yeah, this needs to call update cursor because our cursor is not moving with the camera, right? So right now the cursor is on the screen. Inside of this camera, the cursor is at 1, 1 right now. It's at 1, 1. 0, 0 would be top left. 1, 1 is one tile in, one tile down. Cursor's at 1, 1. But if we don't change the camera, let's close some of these. CodePy. If we don't change the camera, if we comment this back out, save this, the cursor is still at 1, 1. It's in a different location though, right? Now it's in the top left corner, the furthest left corner, top left corner of floor. Whereas when we update the camera, now it's one tile diagonal away from Adabot. So the cursor's location is drawn incorrectly when we update the camera. I think all we need to do is just call update cursor location, which again might be more appropriately named render cursor, because this is taken into account the camera lock. And the camera lock gets changed inside load tile grids. You know, again, there's an argument to be made it shouldn't be, but right now it is. It's like the first line. First two lines inside load tile grids are setting the camera lock. So after we set the camera lock, we need to call update the cursor lock. We also probably need to do the same thing for the player. Is Blinka at the right place? No, Blinka's not. Yeah, see, Blinka is supposed to be in the same column as Adabot. But here she's not. She is over 1 and down 1, which is the exact amount we changed the camera. So we need to actually update both the cursor and the player after we change the camera lock. Self.update player. Now Blinka is in the correct spot, in the same column as Adabot, with one empty space in between, which makes sense. That's exactly how it is in the map. And the cursor is in the correct spot now as well. The cursor is at 0, 0 on the screen. inside the camera, which is currently 1, inside the map. It's right here is where the cursor is at right now on my PyGamer screen. Whoops. Which is correct. So if I move right 1 now, it works on the first try. Because before, it was drawn in the wrong spot. Therefore, when I moved right 1, technically the cursor location was changing to the correct spot, but it looked weird because it was drawn in the wrong spot. Yeah. So first time I go down, it also works. Everything works. Okay. So now let's test the camera. If we get to the edge... Okay, we made it to the edge. So if I go right 1 more, camera doesn't change. So we moved to 11. X11. Camera lock we know is 1 because we set it there. 10 plus 1 is 11. We're at 11. We're not greater than 11. So this should be greater than equals. Same thing on this side? I'm not sure. We'll have to test the other way. Greater than equals. I'm sure we need y the same way, though. Okay. I'm going to refill my drink real quick. I'll be back in just a minute. Okay. So if we go to the edge now, we could test the left edge too, but I want to go the right edge first. Does the camera move? It does. And the cursor stays in the right spot. If we go too far, it tries to render more stuff, which we should eventually fix. But for now, let's not worry about it. We go back to the left. It does scoot to the left 1 correctly. Up. Up works as well. So we get, that's interesting. We get index out of range if we go too far down. But if we go too far to the right, we don't. Why is that? So this is on 71, which is set camera lock. It's ultimately back into here on 99, side load tile grids. Which then goes inside build tile list. So why does this go out of range when we go too far down, but not when we go too far to the right? How far can we go? Can we just keep going to the right forever and ever? We're on 10, we're on 11, now we're on 12. It basically just started over. But it's one tile higher. On the right side of the screen, we see Adabots and hearts. On the left side of the screen, we only see hearts. There's ohms as well, but ohms are in the same row as the hearts. So on the right side of the screen, we see both of these two tiles. And on the left side of the screen, we only see this top row. But why? Can we just keep going? Seems like it. Just go forever? No, eventually we reach the index out of bounds. Like we have one whole extra copy. One whole extra copy. Because we have two layers? Go look at this logic again. So, I mean, at the end of the day, we want to cap this wherever we're moving. So I think, again, we should probably be passing the XY location to this. And then inside of that function, we can check the new location, whether or not it's in bounds of the map. And if it is, then move it there. And if it's not, then don't. Just ignore it. Right now, that logic would have to occur here before we change cursor lock. So let's write the logic, and then eventually we'll move it inside of this function, or maybe we'll make a new one or something. So if it's outside the bounds of the map, that would be map object width and map object height. If new lock x is greater than or equal to my game map object width really we want to not do anything. We want to can we pass? Does that work? Pass is only going to pass inside. Can we return? Or continue? I think we should structure this the other way. We should say if it's less than the width, then we will do these things. And we'll also say and new lock x greater or equals to 0 and new lock y less than my game map object height and greater or equals to 0. Okay, what do we need? Slashes or something, right? I like that though. Format. Okay, what's wrong? Simplified chained. Sure. Okay, put it into one sort of three-way comparison. The width is greater than the location, and the location is greater or equal to 0. Okay, that works. Yeah, let's do it to this one too. Okay. I guess these maybe fit on one line. Okay. Thanks, PyCharm. So if we're in bounds, then move the cursor, update the cursor location. So now if we get to the edge, it should just stop moving. Okay, we're off by 1. No. Well, it didn't move. We're off by 1 in the camera moving logic. So all of this stuff should be inside of here as well. Yeah, we shouldn't move the camera if the cursor is trying to go out of bounds. There we go. Can't go to the right anymore. Scooch back over here where it's easier to see. Down. Can't go down anymore. Can't go right or down anymore. Let's check the other sides. Top side. Okay, can't go up anymore. Left side. Can't go left anymore. Perfect. Okay, now we're bounded by the map size, which is perfect. And the camera will move around to follow the cursor. It would be nice if maybe the camera would always try to stay centered on the cursor if it could. That way, like, the camera would scoot over, like, now to the left one. We could start seeing more stuff before we get all the way over there. But let's not worry about that just yet. This is functional, at least. Do quality of life stuff later. All right. So let me update the repo. Okay. All of this stuff was new. All the cursor stuff was new. We're hard coding at 1, 2 before. Maybe that's how we tested the camera last time. Okay. Looks good. Let's also update CodePy. PyGamer Tilemap render. Let's call this, let's change the name of this. Let's call this PyGamer Tilemap Simple Test. Simple Test. Let's update it. CodePy. We can't check the difference of it anymore because now it's brand new, but that's all right. We also had move logic. Okay, so some games are going to work differently, right? Some games might want the D-pad to just be in control of the player. You press up 1, the player moves up by 1. You press right 1, the player moves right by 1. But some games might want to use the cursor to control everything. So then maybe you would move your cursor to the player, press like A or whatever, right? Press a select button to select the player, then move the cursor to another tile, and then press the select button again. So like press A again. And then if the new tile is movable, if it has can walk true, and if the player is allowed to move, you know, that distance, then the player could move to there. So it's kind of like two different styles of movement. I guess one of them, you're more likely to use the latter. You're more likely to use the cursor one if you have different entities that you can move around. So the example I'm thinking of is a Game Boy game called Advance Wars, but it's like a turn-based battle game, turn-based like military battle game. You have tanks and troops, and you move them around, and the enemy has tanks and troops, and you try to capture their base, I think, right? Advanced Wars. Game Boy, I think at Game Boy Advanced it came out. Yeah, so you have a, well, this is a different game. A similar type of game. This is This is an example of it. So you have, so I guess the difference is like there's not one player. There's really not a player. There's only entities. There's all of the entities that are on your team, which you're allowed to move. There's a cursor, which you control with the D-pad. You move your cursor to an entity. That entity has some rules that say how far it can move, what types of terrain it can move over, even stuff like how fast it moves over certain terrain. Like tanks move faster over roads than they do, you know, trees or whatever. So there's not one player. There's just entities. And then the other one, the other type of movement would be more like, you know, Zelda. If you ever played Zelda, where the D-pad just directly controls the player. Anything else that's an entity is probably like a monster or something else, right? Like something that the player does not explicitly control the movement of, other than maybe by like pushing it or something like that. And so, you know, what I'm making here is a Tilemap game library. It should ultimately be able to do either. It should be able to support both of those two types of movement. And one way for it to support both types is, just like we have here, doing all the logic inside of CircuitPy instead of doing the logic inside of the game object. But some of it I do think should be offloaded, and we should provide enough functions that CircuitPy could work either way. What is this? What is this extra offset? What is this extra offset? Map width. So the total width of the entire map in tiles, which on our map it's 12. Minus the camera width, which is 10, times underscore y, which is the current row that we are looking at while we're looping through the height of the camera. So this extra offset represents all the tiles that are above the camera. Because if the camera, if this y is above 0, let's step through this with 0, 0. So if we're at 0, if the camera's at 0, 0, the upper left corner of the camera, if that's on 0, 0, the map width is 12, the camera width is 10, 12 minus 10 is 2. The first iteration we're on 0. So the first iteration we times by 0, the extra offset is 0. The second iteration we're on 1. So we get 2 times 1. The third iteration we're on 2. We end up with 2 times 2, which is 4. So it's not the pixels above us. And I shouldn't say pixels, it's not the tiles above us. Is it the tiles? It's the tiles that are outside of the camera's vision. Yeah. It's the tiles that are outside the camera's vision. So when the camera's on 0, 0, this is what it sees. Everything inside the walls, including the walls themselves. And so the first iteration, just like we saw, extra offset is 0. The next iteration, extra offset is 2, which represents these two tiles right here. Because in order to find this tile in the big list of tile indexes, this big list here, we need to skip these two. And in the third iteration, we get 12 minus 10 is 2 times 2. And that's because we needed to skip all 4 of these. So essentially, yeah, that is all the tiles. That is all the tiles outside the camera. Horizontally. First time through the loop, there's 0. We don't have to skip anything because 0, 0 is inside the camera and there's nothing extra. The next row, though, once we get down to here, we would have to skip these 2. That's where the 2 comes from. So yeah. Extra offset represents tiles outside of the camera's vision. So if the camera was on 1, 1 instead of 0, 0, let's reason about this a little bit more. The camera was on 1, 1, like this. How does it work in that case? X and Y are 1. Width is still 12. Map width is still 12. Camera width is still 10. So we still have 2. Height is still 8. So we're still counting 0. So we still have 0 the first iteration. We still have 2 the next iteration. So why does nothing in here look at X or Y? Why does nothing inside here care where camera starts? Shouldn't it? But it's working, so maybe it doesn't need to. I'm not sure that I understand why just yet. Start index? Start index doesn't get set. Start index doesn't get set anywhere. Okay, this is declaring the function, but it hasn't been called yet. Okay, start index gets set here, which is after the declaration of this function, but before it actually gets called. So start index is the y that got passed. So let's say we're going to do 1, 1. We got 1 times the camera width, which is 10, plus x, which let's say it's 1. So 10 plus 1 is 11, plus the extra offset, which if we're at 1, 1, extra offset is the map width, which is 12, minus the camera width, which is 10, 2 times 1, because we're at 1, 1, we're saying. So the extra offset is 1. So then 10 plus 1 is 11, extra offset is 1, 11 plus 1 is 12. Start index is 12. Okay. So start index. Start index is what's making this care about x, y. That makes sense. Okay. Yeah. Because start index gets set based off of what the xy coordinates of the camera are. Start index gets referenced inside this function. So that's making it account for where the camera started. That makes sense. Oh, this is on still. Nope. Get on it later. Probably a while ago, wasn't it? Yeah, it totally is. Let's go back here. I don't know. Oh yeah, there are some folks in the YouTube chat. Sorry, I have not been keeping up with the YouTube chat. If you're still there, Alvaro, which I think is Fede too, right? Yeah. Oh, now I hear myself. Let me pause that. Volume it down. I have not been watching the YouTube chat, and there's not timestamps on there, so I don't know how long ago you said anything. But hello to Alvaro, first of all. Thanks for checking this out. And let's see, it might be because object remembers X and Y of the camera. Yeah, I'm not sure how long ago that was or what I was looking at then. But yeah, cool. Yeah, thanks for tuning in. Appreciate it. Hope you're having a nice nice day. I don't know exactly what the time zone is like where you're at, but I try to keep an eye on the Twitch chat and the Discord I have pulled up as well. Link during the show. Yeah, this is folks still talking about JP's show. But those are the two best places to find me. Okay, yeah, it happened a little while ago. All right, I'll try to keep an eye on the YouTube one as well here. See if we can shuffle some of these around just a little bit more. Yeah, if I scoot that one over, it comes onto the screen. That's all right. $7 p.m. Cool. So you're actually pretty close to me. It's 8. It's 10 after 8 right now. So you're like 1 hour before me, probably. But much further south. Okay. So let's do what we said to improve update cursor lock. Let's make this, I think we should make this accept an XY. It should then change cursor lock inside of it and then update the sprite. Let's we can control click in here. Control click, that's one of my favorite things about PyCharm, being able to control click a function and go inside of it. So we want to accept, and I guess we'll keep the sort of API that we started, where when we, on the public functions at least, when we accept tile coordinates, we've been taking a dictionary. We should document this as well. This is basically the same as everything. XY. And it returns, it doesn't return anything, returns none. I assume, I guess it returns none. I don't know how that works in Python. JavaScript, that would return undefined. Does it return none or does it return nothing? I don't know if there's a distinction in Python. Doesn't matter too much. I'll know what that means. And inside of here, we should take these two lines, basically. My game cursor block X equals, but it's not my game anymore. Now it's self. We're inside of it. Tile chords X. Cursor lock Y. Tile chords, but this is a string. Okay. And then we update the actual XY of the tile grid, which is actually what determines where it's at on the screen. And this is already taken into account the camera location. Okay. Eventually, we should not hardcode 16 here as well. We should have like a tile size, which honestly, I think it's in the JSON. Yeah. Tile height, there must be a tile width as well. Tile width. Yeah. So eventually we should read those out of the JSON and maybe set some properties or whatever on this object for tile height, tile width. For now, everything I've been doing is 16 though, so we'll leave it hard-coded. So we can take this out of here and instead pass dictionary X. Actually, new lock is already a dictionary with XY. We can just pass new lock. New lock. Yeah. There's already a dictionary with XY. So now we don't need these. And we should be able to save this and everything should still work. Not quite though. Just index out of range. Did it move or something? Let's restart those. Huh. 0. Oh, this is a different error. Okay, line 14. Takes 2 positional arguments, but 1 were given. Okay, but it's inside of here at 77. Right. Yeah. So we have cursor lock, right? Yeah. Self.cursor lock. That is kind of weird though, because cursor lock is a dictionary with XY. We're passing cursor lock into this, which is then updating cursor lock. It's kind of redundant the first time it runs, truthfully. But I guess that's not so bad. Just gonna set it to itself. It should be all right. There's probably another place we're calling it. 210. Yeah. Set camera lock. I almost want to split this into like update cursor location changes the values in the dictionary, and then render cursor changes the XY on the sprite tile grid. I almost want to split it. For now, I'll just fix this, which we could do by saying self cursor lock. And ultimately, player should behave the same way, but we'll leave it for now because we're doing the cursor version, not the player version. So now everything should work the same. Go over, we're blocked. Go down, we're blocked. We can't go any farther. Can go back up. Can't go too far. We can go left. We can't go too far. Okay. That's all looking good. So let me copy this back over to the repo. I'll push to repo once I get done for the night here. Save that. Copy CodePy back to simple test. And I think the other thing I want to do tonight is make a new map and document how to save it. Because I remember that saving it is a little bit convoluted, but I don't remember exactly how. To save a map from tiled. So how do we do that? Let's actually say to create a map in tiled. Let's start from the beginning. New, so we go new map. I'm gonna try to document everything here. I'm gonna try to document everything. And I'm gonna save screenshots even too. I don't know, maybe we'll put these in the readme, maybe we won't. Maybe eventually I'll make a learn guide, another learn guide or something that's more advanced than the existing one, but I'm gonna save all of these just so that we have them. Repos. This is CircuitPython tile grid. Tiled game experiments, it's this one. I want a new folder. I'm gonna call it docs, even though it's not like Sphinx docs or anything. This is new. This is tiled new. Okay. So file new. Create a map tile, go file new. New. Should I make this like bulleted list or something maybe? Yeah, I think so. Let's do it that way. File new, set the height and width. And the tile size, which I'm guessing maybe this defaulted to 16 because that's what I set it to before. If you just downloaded tiled brand new, this might default to something else. I don't know. I don't remember. Click on the other chats here, okay. So, but this is the width and height in tiles. So on ours, it's 12 width and it's 10 height. So maybe we'll make one that's 10 by 20. Maybe we'll make one that's 10 by 20. We want 10 by 20? If we go 10 width, then we can't scroll horizontally. It will go bigger than that, but let's document first. Set tile. These are not, what are they? Map size. Set map size, height, and width in tiles. That's what the units are. Tile units. Set tile size, height, and width. And I'm just going to put 16 pixels is the only one we've tested currently, so I'll just leave it at that. Eventually we'll work on different tile sizes, but the thing about it is if we go too much bigger than 16, I mean, really the only options are like if we go to 24, 24 is a little bit bigger, but then we can't fit an even number of tiles on the screen. We have a partial tile showing on the screen because the PyGamer screen size doesn't divide by 24. If we go to 32, then it does divide, but then we only end up with like 5 by 4 tiles visible, which is not that many. There's some games where that could work all right, but 16 is a pretty good spot for the PyGamer because you can fit 10 by 8 tiles on the screen. So set the map height, set the tile height. So let's do make it bigger so that we can make sure the camera, the scrolling is working. Let's make it 12 by 20. So it'll be taller than it is wide. It'll be taller than the screen by like a little over double. We want 1616. I think we want file layer format, CSV, I guess we'll keep. Ultimately, it's going to be JSON that we save it in. I'm going to document these defaults. I don't know if they're defaults all the time or just because I checked them, I set them before, but orientation, orthogonal, gonal, tile layer format, CSV, tile render, order, right, down. Okay. So then we can do save as. Again, I'm just trying to take super detailed notes here so I can follow this next time. Save as. Click. Save as. Choose a name. Choose file name and location. We'll put it here. We'll call this, I don't know, new map 0. Ideally, we'd have a better name than that, but That file exist? LMN, no. No. Tilemap files. Okay. So yeah, I think we want to do this actually. I think we want to do this. Change the type. Change the type. Choose file name and location. Change file type to JSON. So we can do code block JSON. Map tiles. It's in the bottom right for me, but it depends on what OS you're on, I think. And based on that error, I think we need to include .json. New map 0.json. Still got the error. I may not. Okay. Let's do yes. Let's see what happens. Okay. I'm gonna put so that created JSON, but inside of it it's XML. Okay. So choose file name and location. File name should have .xml extension. I'm gonna go back and do that again. We're gonna close that. We're gonna delete that. Delete. File new. Whoops. New map. We'll keep all of this the same. Save as. We'll say new map 0.xml. I think we still want. That didn't seem to make a difference though, right? Because we still saved we still got XML. Let's try leaving that default. Called map files. Save. Okay, we did not get the warning this time. We chose XML and it is actually XML. So we can just actually, this should say tiled map tiles, right? That's what it was, I think. Yeah. Map files, close enough. Map files. Okay. But this is not change. Use file type default. I think we do an export to JSON. That's how we get, because ultimately we need to get to JSON. We can't parse XML in CircuitPython. So now we have an empty canvas that's at the size we set. We don't have a tile set though. We need to go new tile set. Make new tile set. I'm gonna indent this in. So it's kind of like a sub-step. So we click new tile set. We give it a name based on image. Do we want to embed it in the map? I don't remember. I mean, we want to embed. We want to embed a reference to it in the map. We don't want to embed like. Yeah, image. This is under tile sets. I think we do want embedded map. I think so. I'll call this default tile set for now. choose a name. I don't know, default. We'll just put default tile set. Whatever you like. I'm mostly worried about single tile sets. I think you can add multiples inside of this program, and some game engines support multiples, but we do want type based on tile set image. Type based on tile set image. Yes. Yes, embed and map. We'll come back and change it if we don't need it, but it tries to like embed the binary in there or something. That's not what I want, but okay, source. So we go browse, click browse, find BMP tile sheet image. So for me, this is here. Spreadsheet new. Which was modified a while ago. I think it kept its modified date. Must have been the last time I actually changed it. Okay. You can see a preview of it there too as well, so. Image files. Yeah, we definitely want image. Open. Okay. So set the tile height and tile width. In this case, they defaulted correct, but if they didn't, then you would need to set them. Set tile height and width. 16 pixels. You know, eventually we'll support different sizes and that would change, but I'll put it there for now. Margin and spacing. We have 0 and 0 for those in our sprite sheet, but it totally depends on the sprite sheet. Set margin and spacing based on sprite sheet. 0. I'm going to put 0 pixels for mine for now. Transparent color. Yeah, we want green to be transparent. I guess I must have done this last time. Yeah, I must have done this last time and it kept it. But I'm going to document the steps for it. So check use transparent color. Set custom color. And I used all the way green, like 00FF00. Lots of sprite sheets use pink, which is FF00FF, I think. Maybe? Yeah. I think I'm just at a different spot on the line here. Lots of sprite sheets use FF00FF, but I just happen to use green because green, you know, I think green screen, which is pretty much what it's doing. So my mind works with green, so that's what I went with. And I used like true green. Based on sprite sheet BMP, and I'll put parentheses, and I'll put mine 00FF00. Select. Is this? Oh, you. Oh. That's weird. So this is like a color picker, but it doesn't work right. Why is it wrong? I feel like I've run into that before. I don't remember what it was. Anyway, we can just select it this way. Theoretically, the color picker could work somehow as well, but maybe it depends on the BMP file or something? Okay, so now we have a tile set here. Sprite sheet. I called it sprite sheet last time. Doesn't really matter what you name it. Now we have a sprite sheet here. Now we can start. Now we need to make 2 layers. We need to make 2 layers. Okay, so at this point, we're back to here. We have our tile sheet. No, our tile set. We have our tile set. Now we need 2 layers. Can we rename a layer? Yeah. Rename tile layer 1 to background. What did I use here? Background and entity. Call this background. Make a new layer entity. Background. New layer, tile layer, entity. Okay, so now we have 2 layers. On our background layer, this is where we would put our floor and our walls. We do like this one, yep. Let's do this. So we'll just do a nice big rectangle here. Can get as fancy as you want, but for now, I'm just gonna keep it nice and simple. Big old rectangle. And then for entities, I'll put Blinka. I'll put a couple Sparkies. We'll put some Adabots. Put some hearts. Put some ohms. Put a Minerva down here. Okay. Add floors and walls to background layer. Also, we want to, some of this logic inside the code uses can walk and player and name as well, actually, now. So we need to set properties on the tiles in the tile set. Name property for get tile name function. Can walk property for player movement. Player property for specifying the player entity. I spelled specifying wrong. Okay. So how did we not add property? Edit tile set. Now I can add, okay. So let's go back. We want to go back. How did I do that? I right clicked on the name of the tile set and then I choose edit tile set. Right click, tile set name tab, edit tile set. And then click tile, right click in custom properties, add property. And I'll indent these three, because basically these are the steps and then these are the ones we want to make. So add property name, it's a string. This one is named floor. We can, yeah, zoom in. Can we select, yeah, I can select multiples. All of these, I'm just gonna name them all wall. If we wanted to get fancy, we could say like top wall, side wall, corner wall, whatever, but for right now I'm just gonna go name. These are all wall. This is floor, these are wall. This is cursor. Cursor. We want cursor to have a name though? Not sure. Pretty name. Minerva. I think that's how you spell Minerva. It's too bad I can't just give them all. I mean, I guess I could give them all a name property, couldn't I? Could I just go select all? Add property name. Yeah, I can do that. Okay. Blinka. Adabot. Sparky. Heart. We'll do these, we'll just call them blank. Blank. Okay. Now we have name. Blinka has player true. That's the only one. Player. It's a Boolean. True is checked. And everything else needs can walk. Basically everything that is an entity or a background that is not Blinka needs can walk. It's a Boolean. Floor is true. Walls are all false. Which false is default, I guess. So floor is true. We'll say that, let's just do true on Sparky and Heart. And we'll just say false on Adabot, Ohm, and Minerva. Okay. Okay, so save this. I think Control S. Save tile set. Control S. So back to here. I just erased. I just put a floor instead of ohm. Let me fix that real quick. Okay. Can I have a selector tool instead of a painter tool? Set layers. Hit polygons. Select. Doesn't seem like there's a select tool. Okay. Let me... Oh, I guess that's not so bad. Replaced whatever was there with ohm, but that's fine. think that's fine. So let's leave all this. This looks good. I'm going to save the map with Control S. Add entities and player to entities layer. Save map, Control S. And now I think we need to export it. We need to export it. I think it's like file, export as JSON map files. I think this is what it is. I'm gonna document it, but we'll change it if it's wrong. File export as. We'll just make another set type JSON map files. Choose name, location. We can save it here. So I'm going to call this the same thing as my XML file, but I think we want to name should include .json extension. New map 0.json. Save. So now we have these two new files. This looks exactly like our good map 2, which is the one we were working on. So we should be able to copy this. Does it have image? Image? Does. Yep, that's good. Has our bitmap file set. Everything seems fine there. So we should be able to copy this, paste it on the PyGamer. Paste it. New map 0. Yeah, we'll leave it as that. We should now be able to, inside code, change this. New map 0. And I'll pull the camera up so we can see it run. To save it. So if everything works, then we should now have this new map that we just created load on our screen here. We're still moving the camera to 1, 1. So if we go left 1, we should find a wall. If we go up 1, we should find a wall. We got all of our entities. Those are looking like they're in the right spots, right? Ooh, that's a little tough to see there in the middle. And maybe we do that a little bit here. See if we can get it visible there. So now we can see the ohm at the top. We can see the two hearts. We can see Sparky. We can see Blinka. Blinka's in the right spot, right? There's one blank spot between Blinka and the wall. Yep. Blinka's in the right spot. We got our two ohms there. We got our Sparky. There's a blank column between the ohms and the Sparky. Go down, we got a couple Adabots, and we got a Minerva. There's an empty column between the two Adabots and the Minerva. If we go to the right enough, we should find the wall. We did. If we go down enough, we should find a wall, and we did. So our new map is showing correctly, it looks like. Perfect. So yes, that is, we can save this. I don't think I changed anything, but let's save it anyway. So that is good, I think. Yeah. Yeah. Okay. This is kind of implied, but I'll put copy .json file to CircuitPy. Okay. All right, this is good. I kind of remembered most of that stuff, but I knew there was a lot to it. You know, creating the tile map, setting the properties, all those things. we didn't actually test the properties because we're not doing player movement. We'll do that, I think, at a later time. I think I'm going to call it a night for now. Do we still, we have the A button. I guess we can test the get tile name, right? We can look in here. Oh, no, this is the wrong terminal. We can look in here. Can check the camera. Let's go to tile with something on it. Ohm, if I press A, yep, ohm, it found it. Heart, it found it. Sparky, yep. Floor, yep. Wall, yeah, okay. So name is working. We could test can walk, but we'd have to switch over to player movement instead of cursor movement. And I think I'll save that for another time. But I'm going to call it for now. Yep, thank you. Thanks, Alvaro. Again, appreciate you checking it out. And yeah, I'm happy to get all this stuff done. I guess the one other thing I'll do here is I'll push the repo. Let me add these. And I'll even update the simple test, I think. I think the only thing that changed is the name of the map file, but that's all right. We'll put the new map file in there. And now we have a good set of instructions for next time I come back to this, so I can create new maps. And I think maybe I'll work on this weekend when I stream on Saturday. So if you found this interesting, then you can check me out. The normal times that I stream are Saturday at 10 a.m. Central. So if you like this kind of stuff, you want to see more, that is when you can tune in for more. But for now, I am going to head out. So thank you all, and I will see you next time.